Do you know that there are same number of rational numbers as natural numbers? What it means that if n is the set of natural numbers and q is the set of rational numbers, then cardinality of n is same as the cardinality of q. To understand the concept that why cardinality of natural numbers is same as the cardinality of rational numbers, let us understand some basic concepts. So let's start with relation. A relation from a non-empty set A to a non-empty set B is a set of some ordered pairs of elements of A and elements of B. So here, suppose we are representing these ordered pairs with these arrows, and since I'm talking about ordered pairs, that is why the elements are not connected with line segments. These are connected with direction arrows, right? So it represents order. So I'm not taking all the ordered pairs. It's not necessary to take all the ordered pairs. Some of the ordered pairs form a relation. Okay. Now let us talk about function. A function from a non-empty set A to a non-empty set B is a rule by which each element of set A is connected to exactly one element of set B. Here in the function, it is a special kind of relation in which you can see that first of all the elements of A are in use, right? Every element of A is connected to some of the element of B. Here these elements of B, these are called images. Only those elements are called images which are associated with some of the elements of B. So this 6 is not image of any of the element of A, and it is written like f of 1 is equals to, suppose f of 1 is connected to 46, so f of 1 is equals to 46, and in this way f of suppose 6 is equals to this is connected to 12, so f of 6 is equals to 12. Okay. Now second thing what we mention in the definition of function is that each element is connected to exactly one of the element of B, right? So if we join this 7 with 6, so 7 will have two images, right? So that will violate the condition of function, right? In the relation it was not the condition, we have seen this, but in function every element of A should be an image and exactly one image. Okay. Now let's talk about one functions or injective functions. So injective functions are the functions in which no two elements of A have same image. Okay. Suppose here if one more element is there in A and we connect this element to 6, we map 5 to 6. Now this function is not a 1 function. Why? Because 1 and 5, there are two elements which have same image 6, right? So that will violate the condition of 1 function. In 1 functions, two different outputs have different images. Two different elements have different images. Okay. Now here you can see that some of the elements here in set B may be left out. Okay, there are possible elements which are which are not the image of any of the element of A, right? And also since the function is 1 each element also according to the definition of function, each element is necessarily connected with some of the element of B, right? So there are either equal elements in both the sets or set B has more element, and that's why cardinality of A is less than or equal to cardinality of B, right? Nice. Now let's talk about a different kind of function, onto function or surjective functions. So these are the functions in which all elements of B have some pre-image. Okay, there may be a single pre-image, there may be more than one pre-image. So here you can see that all the elements of B are now connected to some of the element of A, right? And here it is not necessary that the function is 1 1. So two or more functions like two or more elements of A like 1 and 3 are connected to the same element, right? So it is not necessary that this function is 1 1. So onto functions have a condition that all the elements of B have some preimage. Okay, now here, since all the elements have some pre-image, moreover, uh, one element may have more than one pre-images. So from here we can conclude that this set A will have either equal or more elements than set B, right? So here cardinality of A is greater than or equal to cardinality of B for onto functions. Okay. Now if we talk about 1 1 onto functions, then these functions satisfy the condition of 1 1 as well as the condition of onto functions. Okay, every element is connected to exactly one element, means no two different elements of A have same image, as well as all the elements of B are images of some of the elements of A. So according to 1 1 function, number of elements in A is less than equal to number of elements in B, and according to onto function, number of element in A is greater than or equal to number of elements in B. So since 1 1 onto function satisfy the condition of um, both these equations, that's why number of element in A should be equal to number of element in B. So here we can conclude that if two sets have equal cardinality, then there exists a 1 1 mapping or 1 1 function between both the sets. Okay, so if there exists a 1 1 mapping, means cardinality of both the sets is same. Now with this concept, let us see the cardinality of natural number is equal to the cardinality of whole numbers. Okay, nice. So let us define a map from natural numbers to whole numbers, which is 1 1. So join 1 from 0, 2 from 1, 3 from 2, join 4 to 3, 5 to 4, and in this way define a map like fn is equals to n minus 1. Now here you can see the that the function is definitely 1 1, and as well as all the images have a all the elements of W as a pre-image, and that's why the function is 1 1 onto, and that's why cardinality of natural number is equals to the cardinality of whole numbers. Now let us see that cardinality of natural number is also equal to the cardinality of integers. Now this seems something interesting. Now let us define a 1 1 onto map. Join 1 with 0, then join 2 with 1 and 3 with minus 1, then connect 4 with 2 and 5 with minus 2, then connect 6 with 3 and 7 with minus 3. Now here also you can see that every element in Z has a pre-image, and and no two natural numbers have same image, right? So the function is 1 1 onto, and that's why cardinality of natural numbers is also equal to the cardinality of integers. That means that on the number line there are exactly the same number of integers as that of natural numbers, right? So this seems something interesting. Now let's make the things more interesting by establishing that cardinality of natural numbers is equal to the cardinality of rational numbers. So let us start with xy plane. So this is x-axis, and this is, here we have y-axis. Okay, now Now we know that a rational number can be written in the form of p by q, where p and q are integers and q is non-zero. Also, here in the um, xy plane, we will deal only with grid points. Okay, so the points in which both the coordinates are integers, like 0 0, 1 0, 1 1, and so on. For every coordinate x comma y, we will write it like x upon y on this um, on this xy plane. So every grid point will be associated with some of the x by y ratio. Okay, now some of the ratios here may be possible, those are undefined. Suppose this is 0 comma 0 and in denominator it is 0, so it is undefined. This is not a natural number. Here also there's a point 1 comma 0, so we will write 1 by 0, and here this is also undefined. So all the numbers on x-axis are basically undefined. I mean all these numbers which we are forming with our concept, which we are defining. So according to that, the numbers obtained on x-axis will be undefined, right? Okay, now what do we have to do with these numbers? We will start with 0 comma 0, and first of all we will move towards right up to the next grid point. Okay, which is 1 by 0, obviously undefined, but we will see what to do. Now move upward, then move left up to minus 1 by 1, then move downward, then again move in the right direction, and in this way move on a spiral. Okay, form a way which looks like spiral. Okay, so let us define the direction each time. So here, right, upward, left, downward, right, upward, left, downward, right, and in this way move on a spiral. Now let us establish one-one mapping from natural numbers to rational numbers. So connect 1 with the first defined number on this spiral. Since this 0 by 0 is undefined, leave it. 1 by 0 is undefined, leave it. And take this 1 by 1. So make f1, or you can represent like these arrows. So connect this one with 1 by 1, 1 upon 1, which is equals to 1. Here I am taking natural numbers, here rational numbers. Okay, now other defined number on this list is, on this spiral, it is over here. First one was 1 and second is minus 1. So connect I'm sorry, the second one is this 0 by 1 over here, right? So connect this 2 with 0 by 1, which is equals to 0. Then connect the 3 with this minus 1 by 1, which is equals to 1. Now as soon as we will reach a number on the list which is defined but repeated, we will skip that number also. So here minus 1 by minus 1 is equals to 1, so we will skip this. Okay, next number on the spiral is again 0, so we will also skip this 0. Okay, we will skip this minus 1 by 1, and we will connect the 4 with minus 2 over minus 1, which is equals to minus 2. So in this way you can see that we will skip the repeated numbers. That's why there will the map is 1 1. Basically no two natural numbers will be connected to the same rational number, because we will not take the element twice, right? And every rational number must have a pre-image according to our this concept, this approach of mapping, right? So we can say that if we are mapping the natural numbers and rational numbers like this, then the map is 1 1 and on 2, and that's why cardinality of natural numbers is equals to the cardinality of rational numbers. Interesting, right? Means on the real number line, here we have exactly the same number of rational numbers as that of natural numbers. So till here, what we learned that cardinality of natural numbers, whole numbers, integers, and rational numbers are all same, and this is represented by a symbol which is called Aleph-Naught. In the next part of this video, we will see that cardinality of real numbers is not the same as the cardinality of natural numbers. Means we cannot define a 1-1-on-2 map between natural numbers and rational numbers. Okay. Cardinality of real numbers uh, cardinality of real numbers is not the same as natural numbers. Okay. Cardinality of real numbers is represented with a different symbol. This is called continuum. Okay. And in the next video we will see that the cardinality of real numbers is same as the cardinality of an interval 0, 1. Means on real number line there are same numbers as that of in a small interval 0, 1. Let's say here's a number line. On this number line, if we take this interval, then this number line and this interval have same number of real numbers. Okay, so also we will learn some interesting relations and properties of this continuum and Aleph-Naught. So we will meet in the next video. Don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.